Alrighty, so let's continue. But before, you see that how hard this is actually, right, to work with preferences. Did you like them? Probably no, right? So don't worry. So you'll see that this is actually good. So now I'll tell you that we can work with numbers, okay? Instead of, but all I wanted you to understand is that how we are going to that function, which we will call utility function, from the statement that I like, Behzatçe and 2 chocolate bars more than Muhteşem Yüzyıl and 3 chocolate bars. You see, this statement, we can represent this statement using this, maybe you didn't like, but ugly preference relation, okay? But for some people it's beautiful, so maybe I shouldn't say ugly, okay? So it is actually, so we can represent this statement using these guys, right? But again, they seem, imagine that every time I have to define this, I have to use this wiggly, sort of relation and then say all these kind of stuff. So, but what is more intuitive to us is working with numbers, okay? So you'll see that we'll work with numbers, but as I said that I wanted you to know where those numbers or where that function that we're going to use is coming from. It's literally coming from the statement, I like this as much as this, okay? Or I like this at least as good as this, or I prefer this to this, okay? So basically, this is the case, and some of your friends, they were asking me, Hocam, why did we put, where is it? So why did we put this guy here, okay? I did it so that, because remember we defined these guys, so this x could be in Rn, right? So it's just a matter of saying it. So x1 could be a bundle like this. Okay, so xn1, okay? So it's going to have n components, okay? That's why, I put it as a superscript instead of a subscript, but, you could have also used a subscript, then I would use another subscript, okay? So this is just a way of, expressing stuff. It is just notation, okay? Now, remember, as I told you, that this is basically, it's not, actually, I didn't tell you, but you guys told me that, Hocam, it looks a little bit hard to work with these preferences. So why don't we actually work with numbers, okay? And this is what we will do. But again, you see that, certain things has to be satisfied so that you can work with numbers, apparently, right? Apparently, we learned that you shouldn't be very crazy. And also your preference relation shouldn't be, your preferences should be such that they're not jumping, up and down, or you don't, when you come to a point, up to a point, you say something, and then when you come very close to, that point, then suddenly you change your preference, okay? These stuff that we don't want because we want it, you'll see that we want to take derivatives, in a close neighborhood and such. So it's, we want to use derivatives and such. So for those, we need continuity, okay? So basically, basically this is what we were saying. So if you say this, right? Suppose you say this, why don't we assign numbers to these guys, right? So let's say that you said x1 is at least as good as x2, okay? So why don't we assign some numbers to this? So it turns out that given, so let's say this, given these properties, right? Given completeness, reflexivity, okay? Transitivity, and continuity, okay? So given these guys, if these guys are there, it turns out that you can rank all the alternatives, okay? All the elements in this set X, right? Set of all alternatives. You can rank all the alternatives from the worst one to the best one, or from the best one to the worst one, okay? Basically, if you have these guys, then you can rank them, okay? Then if you can rank them, let's say we have this. So x1, is at least as good as x2, okay? Basically, and let's say x2 is indifferent. I'm indifferent between x2 and x3, and x3 is at least as good as x4, okay? So suppose I have this. Then I can just, it turns out if I can, and suppose, I have only 4 alternatives. So if I can rank these guys from best to worst, okay? Then, why don't I assign some numbers? 50, let's say 40. What should I assign to this? 40, right? So this is basically 40, and this is, what do you want me to assign? 1? Okay. Whatever. There's no right. All of them are actually correct. As long as it is or more than, or it could be, remember this allows for 40 as well, right? So anything, like less than 40 or 40 is allowed, okay? But suppose, let's say I put here, as you guys said, let's say 10. I don't know, whatever you said, I don't know, right? So this is basically, so these numbers, you see that I should be able to rank them, then I can assign numbers to them. Then, fine, so this is the case, I can assign numbers to them. So we're going to call these numbers utility, okay? Now we learned, some people were saying, but you see there's a long way to go to utility. Before understanding this utility, these numbers, we should know where they come from, right? You might say that, hocam, I never give numbers. I say, I like Behzat 2 chocolate more than Muhteşem Yüzyıl 3 chocolate, right? This is what you say. You see the link from what you say, how we come here, right? So this is basically, so these numbers, we call them utility, okay? This is basically how much happiness, how much, well-being you get by consuming these bundles, okay? By basically watching Behzat and eating 2 chocolate bars, okay? So these are actually utility, as we said. But for instance, so these numbers represent what we call utility. Remember the satisfaction that you get from consuming these bundles. But, okay, but could I do this? I don't want to assign 50, 40. What about this? I want to assign 5, 4, 4, I don't know, 1, or 0.1. So that you wouldn't think that I'm dividing everything by 10, okay? Is this also okay? Huh? Is this also okay, right? It represents the same information, right? So what I tell is this order, right? This ranking. And then you assign some numbers, but you could have assigned these numbers as well. That's why we're going to say that what matters in utility is actually, it's going to be, like what we call an ordinal, right? So thing, it's not going to be a cardinal thing, okay? So what matters is actually, this is, utility rankings are what we call ordinal rankings, okay? So what matters is, actually, the order. As long as you preserve the order, you can assign any numbers, okay? So the function which is going to assign these numbers to these guys is going to be called a utility function, okay? So this is going to be, so basically this function, utility function u, is going to assign this bundle a number, okay? It's going to assign this bundle a number. It's going to assign this bundle a number. It's going to assign this bundle a number, okay? So there could be another utility function. So you can actually have this, okay, which is assigning another number. But basically we said that it's actually, these numbers themselves, they don't mean anything, okay? But what matters is the order, okay? So these are basically, so the numbers, that's why it's not cardinal. Cardinal, it means that it's related to the numbers, okay? But it's what matters here is the order, okay? So this is basically what we say, okay? So you saw the link from the statement of, for me, I like, or for me, Behzatçı and 2 chocolate bars is at least as good as Muhteşem Yüzyıl and 3 chocolate bars. From that statement, we actually represented via preference relation. We said that if that preference relation on top of that, there is continuity, okay, then we can represent our preferences by a continuous utility function, okay, which is good. Once we have it, good. We don't have to deal with preferences anymore, right? Now we can work with functions. And then later on, remember, what did we say? You guys would like to maximize what? Your utility, right? So that's, and if you want to maximize, you need to take derivatives. And to take derivatives, what do you need? Do you think that you can survive in a world where you have discontinuities? No, right? It's not, derivative is not defined, right? So you need continuity, okay? So basically, so this is the case, okay? So let me write this. So let's actually, so let me give you the formal definition. So this is, so let me write this, then, so let's have this. Then individuals can rank all the alternatives from less desirable to most desirable one. Okay? And then let me write down. And then we said that when we have all these 4 properties, then we can represent everything using a continuous utility function. Okay? You see, it wasn't that easy to convert the statement that I like this more than this to a functional form, right? So we had to go through some steps. And apparently, if we would like to do that, we have to have certain properties there. Okay? So this is basically what we did. So that's why I said that if what we have done in the previous lecture is a little bit too abstract for you, which is perfectly fine, don't worry, but just know that, oh, it's a way of going to this utility function, okay? This continuous utility function. So let me actually write this. So if preferences, we can call this, if preferences satisfy, okay, so we say completeness, reflexivity, transitivity. So you can tell that's why I wrote this, because you can say that, oh, apparently if I need to tell this to my grandma, I can say that all these guys, when they're there, and when my preference relation satisfies these properties, it means that I am someone who can rank all the alternatives, okay? So there is some sort of a consistency, okay? So satisfy completeness, reflexivity, transitivity, and continuity, okay? So there is some sort of internal consistency, and continuity means that you're not jumping up and down too much, okay? Then we actually say they can be represented by a continuous utility function, okay? And you see that why we need continuity, because we want to deal with derivatives, okay? So this is basically the case. So that's why we talked that much, okay? But now you know. It's just there for the utility function. So the utility function is an object like this. So I can either write it like this, or I can just write, like x1, x2, xn, okay? If it's defined in Rn, okay? So x or I can put it like this, x is an element of Rm plus, okay? So basically so utility function is actually, so let's be formal, it's also, so utility function is a function, so it's defined from where to where? It takes its elements from, apparently, Rm plus, right? But what does it do? It takes a bundle, right? It takes this x bundle, which is like this, right? It takes this, Behzatçı and 2 chocolate bars, and assigns it a number. Then it goes where? To R, right? So as long as, okay, so now again another question. So it is actually, so like as long as, do you think this would be possible? Because your friend was saying that positive real numbers. Do you think that should be the case? Can I assign these? Can I assign, for instance, instead of these, can I say this, right? So let's actually put -1, -2, -3, -4. No, -2. Do you think this is okay?
Yeah.
Right? So this is okay, but so right, because it preserves the order, right? So it's so it could be, so we can say R, but he's right. Most of the time we're going to assign positive numbers, okay? But it is possible, right? I can have, as long as, remember, it keeps the order, it's fine, okay? So this is basically, so this is a function you see which is defined from here to here, and where, so let me write this, where the variables, okay, x1, x2, xn are the quantities of n goods that might be consumed. Okay? You might consume some of these goods, you might not consume some of them, okay? But basically you see that all these variables, they represent a good, okay? And we call this guy, so this X, a bundle, a consumption bundle, okay? So which might be consisting of all the goods, or which might be consisting of some of the goods, okay? But did you understand why we mentioned those properties? Is it clear now, okay? Those weird stuff, reflexivity, transitivity, and, you know, completeness, okay? Did you understand why we needed them? Because in order to come to the function world, to work with numbers, we needed our preferences to satisfy certain properties, okay? Our preference relation to satisfy certain properties. So basically, this is the case. Okay, so now, fine. So then, can I make this statement? For instance, let's say, let's consider this. So let me actually write this. So let's write it here. So let's talk a little bit about the utility. Some of you might know this, but it's important to have these concepts. Suppose I say that x1 is at least as good as x2. And then I assign x1 50, and I assign actually x2, let's say 10. Okay, so let's actually have this. So, okay, let me write. So basically, x1, x2, and suppose utility of x1 is 50, and utility of x2 is 10. Okay? You see that now, when we are actually working with numbers, instead of this wiggly guy, now I can say what? I can say the you know, like the regular one, right? Non-wiggly one, right? I can say this. You see? So there was a reason why it was kind of you know, represented like that. Okay? So it's basically this I can say. Fine. But you know, like, so can I say that, oh, this is 50, this is 10, then I like x1 a lot than x2? Can I say this by looking at these numbers? Can I make, oh, it's one gives 50, the other one gives 10, so the difference between them is 40. So it means that I like this guy way more than this guy. Can I say? No, okay? So remember, these numbers, they don't mean anything. I could have easily said, suppose this is my best alternative there, let's say, and this is my worst alternative, okay? But I could have expressed this also like this. I could have said, like assign this guy, let's say 50, okay? And I could have assigned this guy 49.999, I don't know, or like this, okay? So it's the same information, right? So we don't know. Remember these numbers. So then, and suppose you have some other alternatives which you were actually giving numbers all in between. I can still give numbers all in between, right? So you see that these differences between 50 and 10 or 50 and 49.99, that difference doesn't mean anything either, okay? So you see that these numbers, all that matters is the order, okay? Or another thing, suppose this is what, like I said, this is what your friend...
You mean my name?
Yes.
Maripjan.
Maripjan, okay? So this is actually what Maripjan says, right? Or it could be, let's say he gives numbers, so his scale is very, different. Suppose he gives numbers like this, okay? So do you think I can compare? So let's say Maripjan said x1 is at least as good as x2, and he also assigned these numbers, okay? So can you say that, oh, for Ayşe Hoca, this guy watching Behzatçı and eating 2 chocolate bars gives much more utility than Maripjan. Ayşe Hoca is getting much more utility than Maripjan because he assigned 0.5. Can I say that? No. Okay? So for utility, you see, it's a concept that you cannot make comparisons across individuals because people's scales might be different. Okay? So this is an example, typical example that I also give in my 101 classes. So I don't know whether they do it here, but like when you go to the hospitals, when I was doing my PhD, when you go to the hospitals in US, okay, they give you a scale. They tell you how would you rate your pain, okay, from 0 to 10. So I broke my ribs and I went there. So it was, you know what ribs are, right? Kaburga. So it's actually, so it was pretty painful, as you can guess. But for instance, they asked me, I probably said I don't know, maybe 7. It was really painful, maybe 6, 7. But for me, I always think that there is something, definitely much more painful than this, right? And there were some undergrads, okay, not like you, but from that region, and they twisted their ankle. You know what it means, bileklerini burku, and they were, screaming, and they were saying 10, right? So it's you see that it doesn't mean people's scales could be different, right? So if you're a very, so you can actually say your pain threshold might be very, different than mine, okay? So then with a twisted ankle, they might say 10, oh, it's really painful and such. And with a broken rib, I might say 6, okay? So you cannot compare these numbers because people's scales could be different, okay? So just keep this in your mind. So whenever you see utility function and whenever you have some numbers, always interpret those numbers as, oh, it makes some sense to me as long as 50 is greater than 49, right? 50 is greater than 40, that's it. But 50, 40, 49 by themselves, they don't mean anything, okay? So basically this is the case. Now, whenever we talk, actually we make another assumption. Remember, I kept saying, so how did I call these? What did I tell them? What did I tell them? I called them? Huh? I called it bundle. Bundle is consisting of what? Elements. what did I say in this particular context? Quantities of goods, right? So why do we call them goods?
How do you measure the services?
Why do we call them goods? What is a good? What does good mean? If you tell your grandma that these are called goods, right? Good has another meaning, right? What does it mean? Okay, we all know what it means, right? So these are actually literally goods. They are not bads, okay? So basically, what do we mean? Whenever we say goods, you see there are lots into words. So whenever we say goods, it actually means that they are goods, good for us. So we basically prefer more of them, okay? Whenever we say. This is now, we're going to have another assumption, and you're going to see that it's going to be very important in this course. And what we call is that more is better, okay? More is better basically says that the stuff that we're going to consume, these guys, the elements that you said, they're actually good for us. They are goods, okay? They're not bads. We can write a utility function for bads as well, so we'll discuss that. But let me write this, okay? So don't forget that we're talking about goods here, okay? So it means that there is this implicit assumption of more is better. So what does this mean? So let me, obviously it means, more is better. But it means that we assume, okay, so we usually assume, let's put it that way, that doesn't have to be the case, more of any, okay, particular xi, basically any particular good, more of any particular good, and no less of the others, okay, is preferred to less of xi. So it means that, for instance, if I keep, let's say, or you can actually call this, suppose, like you have, in a week, you go and Starbucks have I don't know what you like.
No, I don't think this is.
You don't, okay. So like, let's say, or you go to Fiero or whatever, okay? So, or Mozart. Right? So you go and let's say for 3 days, so 3 times in a week you drink coffee, okay? And then let's say for 2 days you eat salad, and suppose that's it, you cannot, like have anything else, okay? So this basically means that you would, suppose you still eat 2 salads, right? But you would prefer 4 coffee, 2 salads, right? To 3 coffee to 2 salads, right? Because your situation is you don't change what's happening to the salad, but you're actually having more coffee, okay? Do you think this is always the case?
It's not, I have a question about that. For example, you wouldn't drink 7 cups of coffee a day, probably, if you care about your stomach.
Exactly, right?
So do we consider the health factor in these bundles or not?
So he's absolutely right. He's like, hocam, more is not always better, right? If you have coffee, if you at some point, it might be like, I put here 10 coffee, and suppose this is a day, right? I put 10 coffees, then 11th coffee is not going to give you any extra utility, but it's going to make you throw up, right? So it's going to be, right, it's going to call what we call a disutility. Definitely. So your friend is right. So what's your name? Jim. Okay, so it's, now I have an easier one. No, don't worry. I'll keep asking yours. But actually, right, so but this is what Jim is saying, right? So it's actually, hocam, I don't buy this. More is not always better, and that's exactly the case. But again, as you can guess, if more is better, things are math-wise, things are much easier, okay? That's why we're going to have, because it would mean that there is some sort of a monotonicity, right? Because what he says is that up to some point, you like something, and after some point you start not liking it, right? But we actually here we want this to, when you have more of one good, it's always better. But you see, this is an assumption, and that doesn't necessarily be true all the time, okay? So, yes?
So can we say that usually the given functions are concave functions?
So we'll come to that, yes, but we can have a little bit, we can have a more general form than concavity. We're going to call them quasi-concave, okay? So you'll see what it means. But basically, you guys are asking all the right questions because this doesn't necessarily true all the time, okay? But you'll see that this is going to make our life easier, okay? But always keep in mind that that doesn't have to be true all the time, okay? So this is basically the case. So this is what I actually meant, right? So we assume more of any particular xi and no less of the others is preferred to less of xi, okay? So this is a very informal way of saying it. But basically, so what does this tell us? So let me actually show you. So this basically tells us that now we have a function, we have numbers, so we can have our xy plane, you'll see. So let's try to understand what more is better. What does that mean, okay? Now, let's see. Let's say an example. Okay, suppose n is equal to 2. Okay, so most of the time, and suppose we have a bundle of goods, which we're going to represent it by x star, y star, okay? Now, I'm going to put my bundle here. So I'm going to put, basically, actually, so we sometimes make an abuse of notation, and we actually said, so you see that this x both represents the good, right? So it could be the series that you watch, okay? And also the quantity of that good, okay? Or it could be the number of chocolate bars that you eat, and also the quantity of that good, okay? So here I'm going to measure the quantity of x, okay? X is going to measure the quantity of good x, and y is going to measure the quantity of good y, okay? So let me put here, so this could be anything, right? So let's say, let's have chips here, okay? If you want, we can have Coke here, beer here, whatever, okay? So basically, so this is the case, so chips and such. So suppose this is your bundle, okay? So x star is here, and y star is here. So if I have more is better, then what can you tell me? So let me divide this positive quadrant, right, like this. So for instance, let me think of these parts. So if I take a bundle here, right? Suppose some bags of chips and some, like bottles of Coke, okay, cans of Coke, or bottles of beer, okay? So what can you tell me about a bundle here? If there is more is better, you would say, hocam, this is better, why, than this guy?
Budget constraint.
Huh? No, we haven't said anything about budget or anything, right? So why it's better? Because it includes more of both goods, right? So this is definitely better than this guy. What about a guy here? Still better, right? Why? You would say that, hocam, this has exactly the same amount of y, right, which is y star, and this is good, this has more x, right? Like the example that you have just written, right? So basically, so this is also better. What about this? It's also better, right? So you see that any bundle that you have in this part, if you have more is better, right? Any bundle in this, you see in this direction, sort of, is actually is better than you would prefer it to x star, y star. So what can I say? This guy here is going to provide more utility or less utility? More, right? So basically that is the case. So let's say this is actually, so we can actually write preferred to x star, y star, right? So any bundle here is preferred to x star, y star. If there is more is better though, right? Otherwise, I cannot say it. So what about these guys here? What can I say about this set? These guys are, right, not preferred. These are worse, right? So basically, so we can actually say preferred to X star. So we can actually say worse than X star, Y star. You see, again, more is better is something that is kind of restricting us. We know that that is not always true, but let's say if it's true, then you see that it helps us to say that, oh, all these guys are better than this guy, and all these guys are worse than this guy. But what about this? What's happening in these regions? Right? We don't know. Why you don't know? You say that, hocam, because here, for instance, I have a bundle, right, which has less of X star, but which has more Y star. So I don't know, right? It's not the case that, oh, I have one good exactly the same, I have more of that good, which I would like, apparently, if there is more is better. Or if I have more of both goods, which is good, right? It's not like that. I'm having more of one good, but I'm having less of another good, okay? So in order to understand, as you know, like Bidirhan was saying, it's actually, you know, you need to figure out, right, what's happening in those regions, and you need to understand, okay, but you give a little bit of X, but you get a little bit of Y star. So what would be the first question that you would ask? What would be the first thing that you would wonder here?
It's the relative preference itself.
Right, so you might wonder, hocam, I want to know, you know, like, okay, this guy X star, Y star is giving some utility, or it's going to make me, you know, like happy to some extent. So let me trace out the other bundles in these regions which are going to give exactly the same utility, right? Which are going to make me as happy as, you know, the same, which are going to give me the same happiness, the same satisfaction as consuming X star, Y star, okay? This is, remember then, what did we say? You are, if this gives exactly the same happiness, we said that you're indifferent, right? That's why this is, you're going to trace out all those bundles, and it would look like, let's say it looks like something like this. And these would be consisting of all the bundles that are indifferent to X star, Y star, okay? Then we're going to call this curve an indifference curve, okay? So this is going to be the case. So basically, we ask consumers, or tell us all the other bundles that you're indifferent to X star, Y star. Suppose they told us these, and then we're going to, you know, connect them, and this is going to be our indifference curve. Do you think indifference curve should be like this? So could you or your grandma, okay, or your grandpa, could we have an indifference curve like this? Obviously it has to pass through this. Do you think this is possible?
No.
Why not? You're too restrictive. Do you think it's possible? Why not?
Because less of both goods are preferred the same as less of more of both goods.
If there is more is better, you said. So
Yes.
then,
At some point in the graph, the same quantity of both goods is preferred.
okay. Suppose there is no more is better. Do you think this is possible?
Yes.
Yes. I could have a preference relation like that, right? I mean, you'll see that I can have, it doesn't have to be the indifference curve. It doesn't have to be, you know, it could be something like this all the time. So let's put these. It doesn't have to be like, doesn't have to have this nice form, but it could be like this, okay? So we'll see. Most of the time, as you guess, oh, hocam, we're going to have this nice form, but this could be the case too. So we'll understand why, you know, like, if this is the case, what's happening? How can I explain it to my grandma? And if this is the case, what's happening, right? How can I explain it to my grandma, okay? So basically, so this is actually what we mean by an indifference curve. So let's stop. So next class we'll see the formal definition of indifference curves and we'll continue, okay?